Good day, students! In the previous chapter, we discussed how laboratory tests are established by method evaluation and how quality control continuously monitors their processes. In this topic, we will expand on these ideas to discuss the concept of quality improvement using the Lean Six Sigma. For our learning objectives, at the end of this lesson, you are all expected to determine the basic concepts of Lean Six Sigma process improvement, familiarize the DMAIC methodology in laboratory process improvement projects, and lastly, determine the role of Six Sigma metrics in laboratory quality control. This is the symbol of Six Sigma. Number 6 and then this one, this is the sigma. So sigma is the 18th letter of the Greek alphabet and translates to S in English alphabet. This is actually the lowercase sigma because this one, the uppercase sigma, refers to mathematical sum. So this means 6 standard deviation. This is actually a problem-solving methodology, and this focuses on the 6 standard deviation distance from the mean in both directions instead of the usual 3 standard deviation distance. This graph of the normal distribution underscores the statistical assumptions of the Six Sigma model. So if you assume that your business process operates like a normal distribution or bell-shaped curve, then there are certain assumptions that can be made. So the process performs within about 3 standard deviations from the process average. And if we define the quality of the process using the upper and lower specification limits, then a Six Sigma process is one where the nearest specification limit is at least 6 standard deviation away from the average. And the number of standard deviations from the average and the nearest limit is also called the sigma level. And sigma levels equate to a yield percentage. So this yield percentage also refers to the success rate. Let's compare the 3 and 6 sigma. The common probability dictates that 99.73% of all outcomes will fall within the 3 standard deviations, either above the mean or below the mean. So this is the 3 sigma concept, and for most purposes, this is a fine system. However, there are very few scenarios in daily life or most professions where 99.73% certainty or accuracy is not acceptable. And with modern manufacturing techniques, the massive amount of material output means that even the remaining 0.27% of the whole is still a significant number. Particularly, for example, in the manufacturing of vehicles, where safety is one of the primary concerns. This 0.27% defect rate is literally a killer in this case, and this will result in a functionally massive number of defective parts even though the percentage looks small. And after all, in an industry, for example, where parts manufactured are measured in multiple billions, this one still represents 2,700 failures per million parts manufactured. And this is where Six Sigma comes in, ensuring that 99.999% of the yield or the success rate works as intended. And we have 6 standard deviations outward from the mean. And this reduces parts per million defects to only 3.4. So this is a more acceptable number and might be one of the best that we can hope for. Let's take some examples so we can differentiate further 3 sigma and 6 sigma. For the numerical difference, in 3 sigma, we have more than 1/6 part or 1.66% deviation. And in 6 sigma, it's only 0.83% deviation. And the 3 sigma represents 2,700 defects per million opportunities, whereas it's only 3.4 defects per million opportunities when we are talking about 6 sigma. The accuracy of 3 sigma, we have 99.73%. For 6 sigma, it's 99.99966%. And for the production management, the 3 sigma focuses on the manufacturing process, whereas the Six Sigma is more inclusive, extending to every essential business process, from IT, manufacturing, computing, banking, and telecommunications, and even healthcare, of course. And we have here some examples of Three Sigma. For example, in Three Sigma, we have 135 wrong surgical procedures performed across Canada. That's per week. So 135 wrong procedure. But when Six Sigma was applied, there is only one surgical procedure performed across Canada in 192 years. So the accuracy of the procedure is higher. The defect is lower. Another thing, in Three Sigma, there are 54,000 checks that would be lost each night by a single large bank. Applying the Six Sigma, only 4 checks would be lost in 3 months by a large bank. And for invoices, for example, 4,050 invoices would be sent out incorrectly. That's each month by a modest-sized company. Whereas applying the Six Sigma, only 2 invoices would be sent out incorrectly. That's in 50 years by a similar company. Let us take the real-world example. Consider this data based on Amazon shipments. So Amazon processed around 36.8 million orders. And let's assume that each order error cost the company an average of $35. So this is a very conservative number, considering that costs might include return shipping, labor to answer customer phone calls or emails, and of course, labor and shipping to write a wrong order. So we can see in this situation that even a 1 sigma shift, for this example, 5 to 6 sigma, will enable the company to save a high amount of money, considering the difference between $300,000 and $4,000. So that's how important and beneficial Six Sigma is, especially to business and other industries. So what is then Six Sigma? Six Sigma is a methodology for continuous improvement and for creating products or processes that perform at high standards. And it is a set of statistical and other quality tools arranged in a unique way, and it is also a way of knowing where you are right now and where you could be, or how your company could improve. And it is a quality philosophy and management technique. So in short, Six Sigma is a measure of quality that strives near perfection. But you have to take note, Six Sigma is not a standard, but you are using this method, this process, in order to achieve standards in your institution. Also, this is not a certification, but most of the time, you will need to be certified, or someone in your institution needs to be certified in order for the Six Sigma to be implemented in your company. And another thing, this is not a metric-like percentage. Based on this Six Sigma table, a Six Sigma process only has 3.4 defects for every 1 million times you run the process. So that is nearly perfect. So this one, DPMO, stands for defects per million opportunities. So let's have the One Sigma process. This has only 31% yield or success rate. So that means the higher the sigma levels, the less chance of a failure on a process, which reduces waste, inefficiencies, and ultimately cost, which directly impact the financial cost performance of a company. And this process sigma represents the capability of a company and its processes to meet, or let's say, to exceed its defined criteria for acceptability. And let's have, for example, in the laboratory, this could refer to assay performance, turnaround time, number of rejected samples, specimen transport, or even relaying of critical values. So by lowering defects, the quality care is also improved, and cost savings are realized by eliminating waste such as supplies and materials that we use for reruns, unnecessary steps in the process, and also the staff time. And also, I have here the detailed table showing the DPMO and the yield values and on what sigma level they belong. So to put this in perspective, as per CLIA 88 guidelines, most proficiency testing requires 80% accuracy rate. So this translates to around 200,000 defects per million tests, or 2.4 sigma. So this one, so it's near 200,000. So this is the requirement of CLIA for proficiency testing. So that is for the scala of 6 sigma. 6 sigma got started in the electronic manufacturing processes at Motorola in the 1980s in the USA, and since then, it has been applied as a process improvement methodology across the range of industries, like from IT, healthcare, sales, finance, and even in military. And the term 6 sigma was coined by Bill Smith, who worked as an engineer in Motorola. And also, in 1987, Motorola officially launched its 6 Sigma program because they have saved approximately $17 billion from 1986 to 2004 because of this 6 Sigma. And also, in 2002 to 2003, the Green Belt certification became the criterion for promotion to management roles. So what is this 6 Sigma? So this one refers to deviation or dispersion from ideal level of operations, where each level of sigma starting from 1 up to 6 allows for fewer defects. And the value of 6 here means that for every millions of chances, there are only 3.4 defects, which translates to 99.99966% success rate. And 6 Sigma gives you tools and techniques to determine what's making the test process slow down. How can you eliminate the delays, improve the process, and fix further issues along the way. And 6 Sigma also aims to reduce time, defects, and variability in processing. And because of 6 Sigma, you can produce a defect-free product to 99.99966% of the time, allowing 3.4 errors per million opportunities. And 6 Sigma also increases loyalty towards the brand and improves employee morale, leading to higher productivity. Now let's have these people and companies that benefit greatly because of the implementation of 6 Sigma. First, we have Dabawala. A Dabawala is a person in the Indian city of Mumbai whose job is to carry and deliver freshly made food from home in lunch boxes to office works. So they pick up around 175,000 lunches from homes and deliver to their customers every day. And take note, because of 6 Sigma, only one mistake is made in every 6 million deliveries. So that makes an accuracy rating of near to 100%. So this is more than 6 Sigma. And another thing for the Bank of America. So Ken Lewis, he said, sustaining the intensity of our 6 Sigma work is critical for Bank of America to achieve its strategic goals. 6 Sigma has enabled us to generate more than $300 million in the first year productivity gains for the company. It has also had a significant impact upon the leadership team with our personal education and certification as 6 Sigma Green Belts. So now, by these examples, we can see the benefits of the 6 Sigma if we implement it in our own company as well, and if we certify the different individuals that would take charge of the implementation of this process. There are several different ways to implement 6 Sigma, but the most common involves 5 stages represented by the acronym DMAIC, or the DMAIC method. So that stands for Define, Measure, Analyze, Improve, and Control. And we have another one, the DMADV. So this stands for Define, Measure, Analyze, Design, and Verify. So the second method, we use this one when developing a new process or when the DMAIC method has failed to correct an error-filled process. So for the sake of this discussion, we will only focus on the DMAIC method. First, define. So in this phase, you define project goal or deliverable that is critical to quality. So this means you determine what issues or problems you are facing, and of course the opportunities for improvement, and also you have to consider the requirements of your customers. So in short, in this phase, you look at the process as a whole. Like for example, you have a problem in the releasing of the results in your laboratory because the releasing of result is always delayed. So you want to know what you can do about this one to improve the process. So that is in the define phase. Next one for the measure phase, measure baseline performance and related variables. So in this phase, you collect data to measure the process. And the point here is you determine the difference between the current process and your desired process. Like for example, in your problem, you determine the current number of results that are released within a day and the time of the releasing of these results. And you can also include the number of staff per shift because this might contribute to the delays of the result. And also, you might consider the time the request was received up to the time the result was released, the turnaround time. So you have to consider everything that could affect the issues that you are facing. And next one, analyze. Analyze data using statistics and graphs to identify and quantify the root cause. So in short, you determine the cause of defects or inefficiencies. For example, in analyzing your situation, you found out that there is a delay in the transport of sample. So this affects the relaying of result or the releasing of result. And another problem that you have encountered is stat request was not flagged as emergency. So those are what you have found in your analyze phase. So next one, what you're going to do is you will proceed to the next phase, improve. So improve performance by developing and implementing a solution. So this process involves making changes to the process and ensure that the defects are addressed. For example, because the specimen were not flagged as emergency or stat, you want to develop a color code for emergency department to make them easier to spot among routine samples. Or this could also mean automating a process to reduce human errors and preventing ergonomic injuries. So that's how you will improve your issues. Next one, for the control phase, you control factors related to the improvement, verify the impact, validate benefits, and monitor over time. So this means you make regular adjustments to control new processes and future performance so that you can do better next time. And you also make sure, for example, that you are not going back to the old methods of doing things. So you have to orient your staff on that. Like for example, based on the changes that you have made from the issues that you have faced, there is a 90% of results that were available within 30 minutes. So you improve the releasing of result. So this means you develop, you document, and implement a monitoring plan to ensure the new process is maintained. And this might also mean ongoing training for lab staff to refresh them in the new methods. So that is for the DMAIC method for Six Sigma. What about the lean? So the lean is used to remove a part of the process that does not bring value to the customer. So we call this as the waste. So if Six Sigma was designed to remove defects or errors, the lean process was designed to remove waste. So that means Lean Six Sigma is a combined methodology that focuses on eliminating problems by removing inefficiencies and waste. So this will improve working conditions and will ensure that customers' needs are better satisfied. So combination of these two ideas provides a positive synergistic impact on process and of course quality improvement. So for the goal of the Lean Six Sigma, we have again remove waste or muda, that's the Japanese term for waste. We use that for Six Sigma, that's for the lean, and of course reduce variation or defects or errors. So that's for Six Sigma. So this waste, the muda, this is anything that does not add value for the end customer. So overall, these are the benefits of Lean Six Sigma. Increased profit, standardized and simplified process, reduce errors, employee development, and value to customers. The Six Sigma methodology also provides the use of colored belt tier system for its certification. So you can also acquire this online, but there is a hierarchy to follow. You have to start at the white belt level. So this just demonstrates a basic or introductory level of knowledge to the fundamental concepts of Six Sigma. All the stuff involved in your laboratory will likely need at least this level of training. Next one, for the yellow belt, this indicates that you have learned the specifics of how Six Sigma works, how its disciplines are applied to the workplace, and where is it best to concentrate your time as you learn the process. So you also prepare the staff to be team members on Six Sigma projects. Next one, we have the green belt. So this certification focuses on advanced analysis and resolution of problems related to quality improvement projects. So you lead and manage projects while also providing support to the black belts. And for the black belts, what they do is they are signified that they are already an expert in the Six Sigma philosophies and principles, and they are known as agents of change within an organization who lead project teams. Usually they are on a full-time basis. And they also mentor the yellow and the green belts. Next one, we have the master black belt. So this level of training, the staff here are responsible for training the black belts in the organization or laboratory. So a master black belt designation is given to those who are trained in many performance improvement methodologies and have many years of leadership, project management, and mentorship experience. And lastly, the champion. So this level of training is usually given to a high-level executive, division leaders, or directors responsible for overall quality in an organization. So in short, they oversee the entire process and are especially important at the beginning of Six Sigma implementation when changes are most likely to arise. So what are the applications of the Lean Six Sigma in the laboratory? Of course, to reduce errors in the total testing process, we have improved safety, reduce stats, improve accuracy of analytical tests, optimize quality control rules, and of course, for method validations. There are two ways to determine the sigma in the laboratory. So as mentioned earlier, we have the defects per million opportunities. So this is a short-term sigma most commonly used that counts defects and convert it to DPMO, and you look up in a sigma table to interpret this one. Next, we have the sigma metric equation. So this measures variation and you construct a method decision chart. Let us compute for the defects per million opportunities using this formula. Example, a unit has 5 parts and in each part, there are 3 opportunities of defects. So what is the DPMO if 10 units have 2 defects? So applying the formula, we have the DPMO is equal to 2. That's the total number of defects found in the sample, this one, divided by 15. So where did I get this one? 15, that's the sample size or the total defect opportunities. So 5 times 3, that would give you 15, multiplied by the total number of defect opportunities per sample, which is 10, this one. So this would give us 0.0133333. You multiply this with 1 million. So that gives us a DPMO value of 13,333. So if Six Sigma performed at 3.4 DPMO, so we have to find in the table at what Six Sigma this one belongs. So 13,333 falls somewhat in this value around the 3.7 sigma. So that's how you're going to compute for that one. Another example. A form contains 15 fields of information, and if 10 forms are sampled and 26 defects are found in the sample, what is the DPMO? So for the formula, we have the DPMO. So the total number of defects found in the sample is 26 divided by the sample size. So in this case, we have 10 forms multiplied by 15, which is the number of defects per unit in the sample. So this would give us 0.17333. and multiply it with 1 million. So that would give us 173,333.33 DPMO. So again, we will have to look for the table on where this value or DPMO value belongs. So 173,333 somewhat falls in this category. So around the 2.4 sigma level. Let's compute for the sigma metric. So you have the formula TEA, or the total error allowable, minus the bias. So here's the formula of bias, divided by the CV. So the bias and the CV, or the coefficient of variation, both of them represent systematic and random error. And the bias here was obtained from external quality assurance records. So this is a systematic difference between the results obtained by the laboratory's test method and the results obtained from peer group mean. Let's take, for example, this sigma metric calculation. So we have 3 levels of cholesterol in CleanChem that was on July 2014. So the CLIA proficiency testing criterion is 10%. So that's the total error allowable. Also, the CV and the biases are given. So again, for the formula, we have the sigma metric is equal to TEA minus the bias divided by the CV. So let's have first this control. So the TEA is 10 minus 3 divided by 1. So that would give us 7 divided by 1. So that's 7. So that's for the first control. Next one, 10 minus 2.5 divided by 0.9. So that would give us 7.5 divided by 0.9 is equal to 8.3. Next, for the third method, we have 10 minus 2.3 divided by 1, so is equal to 7.7 divided by 1 is equal to 7.7. So that's how you compute for the sigma metric. Okay, let's have another example. So this time, this is for glucose methods. So let's see if they are acceptable based on the 6 sigma method. So again, let's have method A. Total error allowable is still 10 minus the bias 2.1 divided by CV 2.3. So this will give us a value of 7.9 divided by 2.3 is equal to 3.4. For method B, 10 minus 4.2 divided by 1.9. So that's 5.8 divided by 1.9 is equal to 3.05. And for method C, we have 10 minus 0 divided by 1.9. So that is 10 divided by 1.9 is equal to 5.26. As mentioned, right after computing for the sigma metric, we have to construct for the method decision chart. And this is how we are going to do this. So for the y-axis, that is where we are going to plot for the percent bias to reflect the observed inaccuracies. And also, on the x-axis, that's for our percent CV to reflect the observed imprecision. So you just have to scale this one. You have to put 0 and the TEA on this y-axis. And on the x-axis, you have to start at 0 and up to the half of the TEA. So in short, we have here the TEA of 10. This is divided by 2, so we have 5 here. Just like this one, you can see 0 up to the 10, which is the TEA, and then 0 and the half of TEA. And for our criteria, we just have to divide the TEA into the sigma level. So just like this one, TEA is 10, that's divided by 2, that would give you 5, that's why you have here. And next one, TEA divided by 3, that's 3.33. So this one. And TEA divided by 4, that is 2.5. So it's right here. And TEA divided by 5, so that's 2. So this one. And lastly, TEA divided by 6, that would give you 1.67. So it's right here. And lastly, you have to check for the acceptability of the method that you are using. So is it word class, excellent, good, marginal, poor, or unacceptable? And another thing, this is also a quick non-technical description of sigma metric decision charts. So more defects, more noise, and more uncertainty. So in this area, that's why this is unacceptable. Let us apply the sigma-metric values of glucose for this method decision chart. So again, on the x-axis, we have the CV, and on the y-axis, the percent bias. So for the method A, we have a CV value of 2.3 and a bias of 2.1. So CV 2.3 and bias, we have 2.1. So it's marginal. For method B, we have 1.9 and 4.2. So that's why you are there. So it's still marginal. And for method C, we have 1.9 and 0. So this one is the excellent method. So among the three, the method C is more acceptable. So that's how you're going to plot the values using your sigma metric and the method decision chart. But there are also computerized system wherein the sigma metric will be automatically computed and the chart will be automatically constructed for you. So you can visit this link for that one. And also, you have here examples of the different analytes with their TEA and sigma scores and this decision chart constructed for them. That ends my discussion. Thank you so much.